So, let's talk about a horizontally launched projectile. I want you to know a few things before you start actually trying to solve a problem that will hopefully help you when you are sitting down to read and analyze what the problem is telling you. Okay, so the first thing you need to remember is that we're going to look at the horizontal components separately from the vertical components. Remember, horizontal goes left to right and vertical goes up and down. Okay, a horizontally launched projectile is something that starts from some height and is launched and it ends up falling downward. Okay, and that makes a half a parabola shape. Okay, some horizontal components that you need to remember. The first thing is that the launch velocity remains constant. And that's your horizontal initial velocity. That's what VXO stands for. Horizontal initial velocity. Okay? Keeping that in mind, that means there is no acceleration in the x direction, which means it's equal to 0. Okay? The distance that it lands away from where its starting point is called the range. And that's your delta x. That's your total horizontal displacement or distance. Okay, let's talk about the vertical direction. The vertical direction is going to be a little bit more helpful for us for most of the problems that you're going to solve, because that's the direction that is going to be generally used to find the time it takes the object to complete its whole path. Okay? When you're missing time, which most cases you are, and you're usually going to have to find time first, you're going to use either equation 1 or equation 2. It's the same equation, okay? And they're the kinematic equation. Okay, and I'll show you an example of that in a minute. Please keep in mind this is a free fall in the vertical direction, or a dropped object, if you will. That means your initial vertical velocity, Vy0, is 0, and your acceleration in the y direction is negative 9.81 or negative 9.8 or negative 10. Okay, I like to use negative 10. Makes life really easy. Okay, so please keep these concepts in mind while you start solving your problem. Okay, so let's look at a sample problem. A ball is launched horizontally from a height of 250 meters. If the ball lands 300 meters away, what is its launch speed? So the first thing is determine what is given and what is being asked for. So a height of 250 meters, that is your initial position. Okay, and it's landing 300 meters away, so you can automatically conclude that it's going to hit the ground, which is your final vertical position of 0. The 300 meters away is how far away it lands, which is your range, your delta x. Okay, and remember there are two things that you automatically know because you remember your concepts in the vertical direction. Your initial vertical velocity is 0, and your acceleration in the vertical direction is -10. What is it asking you to